Now we're going to first prove it by, can we prove it? Okay, so let's have a look. They say to you, prove that triangle ABC is similar to triangle RPQ. Okay, now the write-up is very, very important. And not only the same with the length size, but also the angle size. A would be equal to the first one there, R. Can you see A is equal to R? Yes. And the middle one, B, is equal to P. Let's have a look. B is equal to P. Yes. And the last one, C, would be the last one there, would be equal to the last one over there. So C is equal to Q. And that is the one that we didn't have. So yes. All right. So the same with the length size is the same. Also, it works the same with the angle sizes. Okay. So the write-up, very, very important. All right, so now they say to prove that that is similar. How do we prove it? Either through all sides in proportion or angle, angle, angle. All the angles are the same. Now, if you think of using sides in proportion, can I use sides in proportion? No, because I don't have all of them. I've got an x value, which I don't know, and I've got a y value, which I don't know either. So which one are we going to use? We are going to use angle, angle, angle. Okay, so sorry, I have just forgotten here. You always start off, you say, in triangle ABC and triangle RPQ, the following is the same. Okay, you don't have to say the following is the same. You're just going to say in triangle ABC and triangle RPQ, double dot or semicolon. Then you're going to say, okay, A is equal to R, because that was given. B is equal to P. B is equal to P, because that was also given. And then C is equal to Q. How do I know that? Because remember I told you only actually need to find two angle sizes that are the same, because the third one will automatically be the same. And what is the reason there? Interior angles of a triangle. Thus, triangle ABC is similar to triangle RPQ. Why? Because of angle, angle, angle. Okay, but we were not finished. Number B said, determine the values of x and y. Okay, now very important. We've worked out in A that they are similar. So what does it mean if they're similar? It also means that all the sides are in proportion. Okay, so when they ask you to find the missing value of those x and y's, you're going to always do your smiley write-up. Okay, what is the smiley write-up? Okay, I've just put this in here. This doesn't have to be in your answer. I've just put it here so that we can refer back to it. So you're going to say AB over RP should be equal to BC over PQ should be equal to AC, first and last, over RQ, first and last. Why? Why can I do that right up? Why can I say that they're all equal to each other? Why? Because of all sides in proportion. I have proven that triangle ABC is similar to triangle RPQ. In A already, I've proven it. So my reason there, I have to do the write-up, smiley face write-up, and then I have to write there all sides in proportion. I've proven that those two triangles are similar. Okay, next step, you go and replace AB's value. AB is 4 over RP. RP was Y. BC was 3 over PQ, which was 9. Okay, is equal to AC, which is X, over RQ, which is 15. Okay, now we need to find the link, the one that has the numerator and the denominator visible, or the actual number is there. And the one here, can you see there's one missing a y and there's an x. So our link, I always say this is our key, is 3 over 9. And to find the y and to find the x, we're going to use this link. So you're going to write it down, 3 over 9 is equal to, here I've just worked out y first, is equal to 4 over y. So now we're going to cross multiply. So 3 times y is 3y is equal to 9 times 4 is 36. Okay, let me do it again. Write down your key and let's do y first. We're looking for y. Write it up there. Okay, then you're going to cross multiply. Okay, to simplify that, 3 times y is 3y. 9 times 4 is 36. Okay, how do I get y alone? Luckily, we did equations before this. So y is equal, you divide by 3 on each side, and y is equal to 12. Okay, but now we still need to find x. So you're going to do your write-up, your key, 3 over 9 is equal to x over 15. Cross multiply, 3 times 15 is 45. 9 times x is 9x. Divide with 9 on both sides, and you get x is 5. Okay, let's have a look at example 2. AE and BD are straight lines, and they say prove that triangle ABC is similar to triangle EDC. So first of all, we need to go and see, do we have sides in proportion? Can we use that as our reason? No, because there's missing values again. So what is the only thing that we can use is angles, angles, angles. Okay, angle, angle, angle. Okay, and then number B, we'll look at just now, determine the values of x and y. Okay, so number A said, prove that triangle ABC is similar to EDC, and we said we're going to do that through angle, angle, angle. Okay, so again, sorry, I forgot to write here. In triangle ABC and triangle EDC, semicolon or double dot, you're going to start. Okay, now the link here is the write-up. So I know that angle A should be equal to angle E, and I know that angle B should be equal to angle D, and angle C should be equal to angle C. Okay, so if we have a look here, A should be equal to E, and B should be equal to D, and the two C's are equal. Okay, so let's look at our reasons that we used in geometry earlier on. C1 is equal to C2. Why? Because of vertically opposite angles. And A, how can I get A is equal to E? Do you see that they've given me parallel lines? And now there's a lekker Z there. Alternate angles. Okay, and A is equal to E because of alternate angles. And please remember the parallel lines. AB is parallel to DE, and B is equal to D, also because of alternate angles. Or you could have actually said, but listen, yeah, I've proven 2 already. The third one will automatically be the same, or you could have just used there the interior angles of a triangle. Okay, to prove that the third one will automatically be the same. Thus, triangle ABC is similar to triangle EDC, and why? That is angle, angle, angle. Let's have a look at B, and then we're done. So the first thing is they ask you now to work out side X and side Y. Okay, so don't fear, don't stress. We do our smiley write-up. Okay, so the order, I've just referred to it here so that you can look at it. So first and second, AB over ED is equal to BC over DC is equal to AC over EC. Okay, again, please, your reason here is all sides are in proportion. Why? Because I've already proven that they are similar. I've already proven that those triangles are similar, which means that all sides are in proportion. Okay, then all you do then is you go and replace the values of AB, or the length of it. AB is 7 over ED. ED is X is equal to BC. Where is BC? Over there is Y over DC. DC is 10 is equal to AC, which is 5 over EC, which is 6. Okay, there's my link. Why? Because I've got the top and the bottom value. 5 over 6. Write it down. I'm going to find x first. So 7 over x, I write there next to it. And then I'm going to cross multiply. 5 times x is 5x is equal to 6 times 7 is 42. Divide with 5 on both sides and you get x. It's a decimal number, 8.4, but that is the correct number. Okay, use your link again. Write it down. 5 over 6 is equal to y over 10. Cross multiply. 5 times 10 is 50. 6 times y is 6y. Divide by 6 on each side and you get y is 8.3 recurring. And that is it. Sorry, it was such a long video, but I hope I explained similarity quite well. Okay, people, I want you please to go and write down these examples, number 1 and 2. So obviously you can replay the video again, and then it will help you just to do number 1 and 2 in your textbook that's been asked of you. But it is these examples that I've used just to ease you into it. And then tomorrow we're going to see whether you can try and do 2 on your own. Thanks for watching and bye-bye.